Come with me up the ramp. I want to show you what we're doing. This is a product from Tremco called EWS. It's a high build, heavy duty coating that we're going to be placing on the ramp. You use this in place of pure urethane coatings. It's a little more durable than epoxy coating, and it's called EWS is a Puma product. That's nothing more than a methyl methacrylate blended urethane, which offers more stability and much longer wear over the life of its warranty. What they're doing now is anytime you take an EWS or a methyl methacrylate type of product and you're tying it into a pure urethane coating, which we're doing here, you want to clean the old coating with a EWS cleaner, and that'll retactify the old coating. We need to tie in over top of that old coating, so we're reactivating it with the EWS cleaner. Now, there's going to be questions asked. Why don't we use xylene? Why don't we use toluene? EWS and products that are very similar in the methacrylate lines do much better when you clean with a methyl methacrylate. Methyl methacrylate can react with xylene, toluenes, and other cleaners if they don't flash off properly. So if other cleaners like toluene and xylene get into pinholes and things like that, it's all it takes to set off a reaction. If you clean with toluene or xylene, then you would do it the day before, and you're fine. A methacrylate offers almost 6 times the durability of a straight urethane. It's a much harder coat. It's very similar to epoxy. The difference is between epoxies and methacrylates is that methacrylates cure in an hour or less. You're opening up a ramp the same day, where some epoxies, once they hit around 50 degrees Fahrenheit, do 2 things. One, they bloom, depending which country you're in. You can say bloom or bloom on the surface. That gives it a waxy surface, so it's very difficult to bond multiple coats of epoxy together in colder weather. Where EWS, Tremco's EWS, we've gone down to minus 20 degrees and had a cure up in an hour. Well, I'm going to tell you minus 20, but I'm going to say this. At minus 20, concrete, the internal moisture of concrete can then create its own frost, subternal frost, and that can cause issues. So you have to check that concrete for moisture on the surface, and normally the way you do that, very cold temperatures, freezing temperatures, take a torch, make sure it's not propane, because the byproduct of propane is moisture. Take a little torch from Lowe's or Home Depot. It's MAP gas. The tanks are usually yellow. That's a propylene gas, and if the concrete's frozen, just torch 1 square foot of that concrete, let it cool down to about 80 degrees, and tape a mat or a piece of poly over it real quickly at about 80 degrees. Give it about 15-20 minutes, come back and look at it. If it's wet, you can't start the job. That's how you test in the wintertime. Frozen concrete. That is the #1 test. Concrete moisture we measure with 1 or 2 meters. The TQC meter, concrete moisture meter, which is 0 to 6%, and the Tramex CME4. Those 2 meters are the most prevalent in the industry for measuring surface moisture on concrete. We expect 6% or less. Unusual, because methyl methacrylates do take more, can handle more moisture in the concrete than a lot of urethanes and a lot of other coatings can. So it's moisture insensitive, but within reason. So the limit is 6% or less on a Tramex moisture meter. The model number again is CME4 or the TQC concrete moisture meter. They both have the same scale. Most reasonable is approximately -8 Celsius. We can go down much lower than that, but for crews to test for moisture below -8 Celsius is a little bit cumbersome because you have to do many tests. Concrete naturally freezes up around approximately at -8 with with internal moisture contents of around 3.5 to 4.5% H2O by weight of concrete. They can subternally dew up on you and freeze. So we're pouring cleaner into a pail because we don't want to contaminate our cleaner. And this pail is going to be used to keep our brushes clean, keep our rake's clean. A rake is nothing more than a steel or metal squeegee. And I always pour a little bit in a pail to keep the stuff in the 6-gallon pail. I want to keep it clean. So you've cleaned the old coating. But let's just, we're going to start a new day here. So the first thing I do is I pull out a Tramex CME 4 meter or TQC meter. Okay, turn it on, and we're going to walk right over to the concrete. We're going to measure the moisture. 6% or less. It cannot go over 6%. Now that's high moisture. This stuff is pretty forgiving. So let's go check it. Okay. So we're getting a 3.2. Got it?
Yep.
Okay. And for every 500 square feet, you do a check 3 times. For every 1,000 square feet after that, do 1 check. Okay? So number 2, we're going to take a temperature of the concrete. Right? So watch this. The temperature of that concrete is going to determine how much part B we put into this product. Tremco calls a part B an initiator. Initiator, part B, same thing. Okay? Let's see, now we're at 74, 73.9, 74 Fahrenheit roughly. Got it? The data instructions on the last page. Do you see the temperature up here of the concrete? Okay. What does it say up here? It's
68 to 95.
68 to 95 degrees. And we want to use, and so that's 20 to 35 Celsius.
Mm-hmm.
And we want to use 75 grams of initiator.
Yep.
You got it?
Yep.
Now, this isn't an exact science. You could go to 80, you could go to 90 grams, but you got to stay under 150 grams. See the next temperature up? You have to stay below that. The more experience you gain, the more part B or initiator you're going to put in the product, right, to accelerate. But once concrete hits about 85 to 90 degrees, just be careful. I always add a little less initiator than I do more, right? It's going to cure it. I mean, the UV is going to cure it up for you. Okay, got it? Now we take this pail and we're going to paint primer into all the joints. Yep. You're still good. See what I mean? Still good. We're going to mix, we're going to now create a caulking. Right? We're going to mix, we're just going to mix a caulking, fill those joints. Okay, and we're going to do this today with 372. So, there are 3 different base coats, right, that we use in Tremco for EWS base coats. There's something called 370. That's your everyday normal base coat that you would put on a horizontal or a slope up to around 2% of the concrete, right? In other words, the top part of your ramp would take that base coat, right? There's the second one is called 371. 371 is a crack detailer, much more flexible. 371 is a very flexible base coat. Then there's 372. 372 is a base coat that's, you would know as roller grade, right? Great on ramps, great for upturns, great for cants and coves.
Upturn when you go up a wall?
When you go up a wall, right? So today we're going to use 372 to fill those because I don't want all kinds of rundown. Okay? And we're going to mix the same amount of initiator. Now normally what I do is before I mix this, I watch the cure of the primer. It has to cure. So I start checking that primer in half an hour. And we do not mix this until we're sure that primer is going to kick over. So from half an hour to 1 hour later, that primer should be ready for this. base coat to fill those control joints up, right? So we got 3 base coats. 370 flows like the wind. Got it? If you put it on a ramp, it's gone. It's gone. 371 is only for cracks. And 372 is roller grade, right? And what I like to do with 372, I like to mix 50-50 with 371. Because it's thick. But when I'm doing cants and coves, what we do is we just check the viscosity of it. So you're going to open a pail, and we're just going to check the viscosity. And if it's just too hard to pour into those control joints, then you're going to mix it with the self-leveling base coat, 370. See what I mean? Just so we get some flowability. This is going to thicken that, because now you could take this, understand something, you can't mix the powder, the part B, into that. It won't mix at all. Understand? So what we do is we do this first. In order to bring that down, to mix that, I add it to this, a minimum of 50-50. 50% of that, 50% of that. We're going to do a total of 1 gallon. So we're going to do a half a gallon of that and a half a gallon of that. Everybody got that? Yeah. Right? And if it's too thin, we're going to check it. If it's unreasonably thin, we're going to add more before we put the part B in. See what I mean?
Yep.
Got it? So. Container.
That's not where the dust that's
What I sometimes do is take the thinner base coat, 1 inch on the bottom or a half inch on the bottom of the pail, dump this in and mix it. See what I mean? So it disperses evenly, and pour that into it. See what I mean? Everybody got it?
Do we do this little crack here?
And if you have too much at the end here, you just go on to the left and right against that steel. Good.
I use that after the book. There is go use half minute.
Okay, so that one's next. Why? Because we're creating a walkway, right?
Yeah. Go looking over here. Yeah.
We've primed this concrete with number 70 primer. That's a pure methyl methacrylate. Now we're going to put a base coat down. Now methyl methacrylate is very hard, right? The base coat, to create a crack bridging base coat, you mix polyurethane into the methyl methacrylate. Now that's done at the factory for you. You don't have to mix it. What happens is now you've got a very hard methyl methacrylate mixed with a polyurethane, which is very flexible. And so the base coat is going to have some crack bridging now. It's still going to be tough, but now you've got a base coat with elongation. So that is known as Puma. PUMA, or polyurethane modified acrylate, or in some countries, polyurethane methylmethacrylate. Right? But Puma products are generally a rubber mixed with methylmethacrylate. It would be the same as if you took urethane and mixed it with an epoxy, right? Epoxy is very hard, urethane is very flexible. Mix the two together, what do you get? A flexible, hard material. So methylmethacrylate will accept urethane, but epoxy will not. So there's an advantage with a Puma system or an acrylate mixed with urethane.
80.
80?
80. Should somebody be mixing them on the tail?
I gotta do it from down here because I can't control it up there.
Somebody can work over here. The outtakes. Well, pull it, right?
Yeah, you want to pull it like hot rubber. Okay? So once I get that. Now I'm going to scoop it up.
So is this how it's gonna finish out? With the ridges?
It's self-level a little bit.
Okay. All right, we going for the knees?
Nice west for that rate. Probably half an hour because there's already heat coming off it. Great marks. This. $35, $33.35 is your cutoff point for cure. 65 is all. 65.
Can you get some this way? Great, so we gonna mix up another one?
Yeah, because we're going to be ready.
It's really wet.
Ready, man.
So is this meant to be the self-leveling stuff?
You guys more and fight. Hey, do you want me to sit to this side?
Yeah, I love it. Okay, so we've just done the 570 wear coat. We sanded it to rejection. We used a mix of 2095. That's very large Uniman aggregate. It's a hard silica with a bow hardness of 7 or more. It's great for heavy-duty wear courses, the aggregate. We also used a 2075 aggregate. 2075 is a little bit cheaper, and it's a great filler. You can actually mix the two together, but I like using two aggregates because the smaller 2075 is great to cast into the primer. You still have to have it on site. Any bags that are left over, you can now cast into the wear coat along with the 2095. So this very steep ramp has about a 40% incline. It is sander rejection, and it is extremely high in a friction surface right now. It's cured after about 1 hour, and we're going to get started on the next coat, which is the 970. The 970 is a lock coat. It's going to lock that coat down, lock the sand down. So any loose sand that's on the deck, first of all, we broom it, we blow it off, get rid of as much loose aggregate as possible. Then we're going to mix up the 970. Again, it's the same initiator or part B, the same gram weight per gallon, which we can use today between 75 and 100 grams per gallon. We're going to roll it down approximately 17 mils thick. Pure methyl methacrylate. So here you go. You got primer. That's pure methyl methacrylate, right? It's a very low viscosity, absorptive primer. It sinks into the concrete, and you cast aggregate into it, and then it dries in an hour or less. Then the base coat, we call that a PUMA. And the word PUMA is a European term for polyurethane modified acrylate. Another term is polyurethane methyl methacrylate. So we just want to make sure that there's a clarity. And the blend urethane with methyl methacrylates in base courses to bridge cracks and to cause a little bit of elongation. Then you have the next coat on top of that, which is the 570 wear course. That's the course that you're going to sand or reject. That has maybe 10 to 20% polyurethane. It is also known as a PUMA, polyurethane modified acrylate. That gears up with the sand or rejection, and the top final coat to lock that sand down and create a beautiful finish is going to be the 970 lock coat. And the lock coat is pure methyl methacrylate. It's shiny, but it'll be a heavy friction surface because it's going to go down at 17 mils. This aggregate is almost 80 mils thick. You understand how the friction surface is going to be quite high. That's our goal. It's very stable. It's one of the most stable UV resistant products available today. And the other reason, the 970, another advantage of a pure methyl methacrylate without the urethane in it is the ability to clean it. A pure methyl methacrylate is easy to clean. Anything with a rubber mixed in, like a PUMA or a polyurethane methyl methacrylate, is stickier and very hard to clean. So that's another reason we put that lock on.